Hi, this is Aiden,
This is Alina,
and we're doing Sig 6.
which is definite integrals.
For the first problem, you're finding the area under the curve using integration. So the equation y equals 4 over x is needed to be turned into an integration problem. So 4 over x dx with the bounds of 4 and 1. Because 1 over x is u prime over u, you know it's ln, absolute value of x. The 4 was factored out. Now you can plug in your bounds to the integrated problem. So 4 ln absolute value of 4 minus 4 ln absolute value of 1. And ln of 1 is equal to 0, so it'll be 4 ln absolute value of 4 minus 0.
So for the second one, the integral is already set up for you. So it's from -3 to 1 to e to the x. So once you take the integral, it turns into 2e to the x from -3 to 1. So now we're substituting in. So 2e to the 1 minus 2e to the -3. And that would be your final answer because you don't need to simplify it into a specific number.
For number 3, we have the integral set up with the bounds of -1 and -4, 3 over x. Now you integrate that, and it's 3 ln absolute value of x because u prime over u, so it's the same thing. Same bounds, -1 and -4. Now that you plugged in the bounds, 3 ln -1 minus 3 ln -4, with the absolute value sign, of course. And because of this, you can simplify it to 3 ln 1 minus 3 ln 4. And as you know, ln of 1 is equal to 0, so it'd be 0 minus 3 ln 4. And, 0 minus that is just the answer, -3 ln of 4. For number 4, we're taking the integral of 2 cosecant squared x with the bounds of pi over 2 and pi over 3. The integral is equal to -2 cotangent x, same bounds of pi over 3 and pi over 2. With that, you can now plug in the bounds, so -2 cotangent pi over 2 minus -2 cotangent pi over 3. Cotangent pi over 2 is equal to 0, so -2 times 0 minus -2 times the square root of 3 over 3. So now you can just distribute that negative sign and multiply the two things together, and you'll get 2 square root of 3 over 3. And that's your final answer.